Hello, this is Dr. Mears, and today we are going to be looking at and learning about sums or differences of cubes. So we have sum of cubes, a cubed plus b cubed, and we have difference of cubed, a cubed minus b cubed. And we also have here how you factor those out. So let's take a look at first the sum of the cubes. So x cubed plus 27. So we're looking at this one right here. And what we're going to have to figure out first is what A and B are. And those are derived from A and B here. So x cubed, we can say that our A is x. Now, how did I get that? I'm just going to take a little side detour, and I'm going to write root, and I put x, and I put exponent. And there's an easy way to take the cubed root. So what we're doing here is the root is 3. We need to take the cubed root of x to the third. So we're going to get x to the 3 divided by 3. 3 divided by 3. So we did equals x to the exponent divided by the root. That's what we did here. 3 divided by 3. And we got x. So that's how you take the cubed root. Let's look at b. So now b we know is going to come from 27. So we need to take the cubed root of 27. Now we can do it in the calculator. This is really 27 to the first power. So we could do 27 raised to the exponent, which is 1, over the root, which is 3. And I'm going to show you that on the calculator. So here we have our calculator. So if we put in 27, and then we press the caret symbol right here, that's the caret symbol, and it gets us in that exponent spot of 1 divided by 3. Hopefully you can see that. There we go. That's going to get us to 3. That equals 3. And that's what our b is. Our b is 3. Or we can think about it as what number 3 times itself gives you 27. And so that number would be 3. 3 times 3 times 3 is 27. So either way you want to think about it, you can to be able to find what our A and B are. I just wanted to give you some options. Sometimes people can just see it, and that's absolutely fine. Okay, so let's put it in our formula. So A is x plus 3. And then we have a squared, which is x squared, minus. And so this is A times B. So 3 times x is 3x, plus b squared is 3 squared, which is 9. And this is our answer of it being factored. All right, let's go to number 2. Number 2, we still have a sum, keeping it consistent. And so we have a sum, plus and plus. We have perfect cubes, so that's what we're looking for, perfect cubes now. Just like we did perfect squares before, perfect cubes. Okay, and that's what a perfect cube is here. And so we have, let's find our A and B. Our A is going to be x, which we just did here. And our B is going to be, so now what we have to do is we have to take the cubed root of 64. Now, if you want to think of what number 3 times itself gives you 64, you can. Or in the calculator, since that has an exponent of 1, we could do 64 to the 1 divided by 3. Exponent divided by root. Exponent divided by root. And so that's going to get us 4. And so 4 times 4 times 4 is 64. So B is 4. Let's put it in our formula here. So we're going to have x plus 4 times x squared minus a times b, which is 4x, plus b squared, which is 4 squared, which is 16. And that's our answer. Okay. Let's take a look at the difference of cubes. So we're going to notice that they're perfect cubes here and here, but we have a minus sign separating them. Let's see what that looks like. We have 125 x cubed minus y cubed. So we have a little bit more work to do here, especially because we have this number in front. So we do have to find what A and what B are. Hopefully you're saying right now to yourself, B is Y, because Y cubed. Okay. We have to find A. So the first thing that we have to find is the cubed root of 125. So you can think about it as what number 3 times itself gives you 125, or in your calculator, you can raise this to the 1/3 power because the exponent is 1. Either way, it's going to come out to be 5. So this is going to be 5. And the cubed root of x cubed, you're right, it's x. So now that we have A and B, we can put them in our formula. So A minus B, let's do that. 5x minus y, okay, a squared. And this is where you need to be careful because when you do a squared, we're actually doing 5x squared. So we're going to be doing a little bit more work here. Okay, what's next? Plus this. Now this is a plus. These both are pluses. Plus AB plus B squared. So plus AB, so 5x times y plus y squared, because that's b squared. Okay, we have to simplify this right here. Simplify. Or you can think about it as multiplying it out. So we're going to write 5x minus y. And so what happens is the 5 is squared and the x is squared. So since the 5 is squared, it's going to change to 25x squared plus 5xy plus y squared. And that's your answer. Okay. Let's just, I believe I have a couple more. So I think I have 3 more. So let's do this one. Now we're talking about m to the 6 times s to the 6. And in order to find a and b here, a and b, we are going to use our little cubed root, where we have exponent over root, to be able to take the cubed root of m to the 6. And you're probably going to find a pattern when we do this a few times. So when we take the cubed root of m to the 6, it's really m to the exponent divided by the root. And so 6 divided by 3 is m squared. And so that's what's going to be a, m squared. All right, the cubed root of s to the 6, same thing. It's going to be s to the 6 divided by 3, which is s squared. S squared. Now we have the plus. So we're going to find the sum. So it's going to be a plus b, or m squared plus s squared. And then it's going to be a squared. I'll write this out on top. So m squared, but this is going to be squared again. Okay. Minus a times b minus m squared times s squared plus b squared. So plus s squared squared. So do you see how I'm putting in a, but I'm making sure that it is squared because that's what our formula says. I'm putting in b, s squared, but I also have to square it again because that's what our formula says. So then when we do that, we clean it up a little bit. We're going to have m squared plus s squared. 2 times 2, so we multiply them. That's m to the 4th minus squared s squared plus, we multiply them, s to the 4th. And this, is our answer. So you just have to be careful when you're squaring the a and b here. You might have to do some extra, a little bit extra. All right, number 5, 64x cubed minus 27. And so what I'm going to do is I'm going to put our formula over here. I feel like we could have used it up here. So there's our formula for difference because we have a minus. All right, so we have to find out what our a is and what our b is. All right, so 64. So the cubed root of 64 we know is 4. And the cubed root of x cubed we know is x. Okay. And the cubed root of 27 we know is 3. So For the first one, this is going to be 4x. For the second one, this is going to be 3. And so that's how you find your A and your B. Now let's substitute it into the formula. 4x minus 3. And then here, A squared, so 4x squared plus 12x, because it's 4x times 3, plus b squared, which is 9, because that was 3 squared. We just have one cleanup to do quick, and that's this. 4 squared and x squared gives us 16x squared plus 12x plus 9. And that's our answer. Okay, so I'm hoping that you're understanding getting the cubed roots. Before we were doing square roots, now we're doing cubed roots. All right, and our last one, we have to remember it says factor completely. So I'm looking at this and I know 2 is not a perfect cube. There's no number that we can multiply 3 times itself. If we multiply 1, 1 times 1 times 1 is still 1. But I'm noticing that they both can be divided by 2 and they both have an x. So we can factor out a greatest common factor first here. And that's going to help us, definitely. So let's divide out a 2x. When we divide out a 2x, we're left with y cubed. When we divide out a 2x here, we're left with negative 64. And that's much more doable than this one. And we're still in the difference of cubes, so we're still using this one. Glad I kept it. Our a is y, cubed root of y cubed is y. Our b we know is going to be 4. And I'm going to bring down my 2x. I've been seeing a lot of people forget to bring down their greatest common factor. Please don't forget to bring down your greatest common factor. Okay, a minus b, y minus 4, a squared, y squared, plus a times b, 4y, plus b squared, plus 16, which came from 4 squared. And this is my completely factored answer. This has been factoring with using sum or differences of cubes. I hope it helped.